Okay, perfect. We can get started. So again, good morning, good afternoon, everyone. Welcome to today's session. Today's topic is message queues. This has been a topic long requested, and we really wanted to cover this for a while now, but a lot of other things are going on. So I think we're excited to bring this session today. And I have a special audience today with me. There is Asher with me. Asher, do you want to introduce yourself?
Sure. Hey everyone. I'm Asher Goldberg. I am a engineering manager at Iterable. My team is responsible for all things related to queuing at Iterable. We'll get into a little later what Iterable is, what we do, why we use queues. But we've been using Pulsar for about 4 years now, maybe a little longer, and it's become the kind of default center of all data that moves throughout Iterable between our services and environments.
Awesome. Well, thanks, Asher, and we're excited to have you for today's session. Larry, you want to go next?
Hi, I'm Laurie Hotari, Senior Technologist here at Stream Native. I mainly work on Apache Pulsar in the open source project, in the project as a PMC member, and very actively also participating in contributions and so on.
Perfect. Thanks for joining, Larry. Awesome. And I'm Kundan Vyas. I'm part of the product team here at Stream Native. So let's get started. Um, so today we want to really, Larry and I will get started with, sharing some details about the message queuing capabilities within Apache Pulsar. For the folks who are not familiar with that, it'll be a quick refresher or rather introduction, and for others, it might be a refresher. We'll talk about use cases, some of the importance of why, agentic AI also which is everybody's focus now, becoming in an important area where message queuing becomes an important infrastructure which we can leverage. We'll also talk, and then Larry will get more details into, the internals of some of the queuing capabilities. And we'll still, I think it would be a little more lighter session, and then we want to make sure that we give opportunity for Asher to talk about his success story with Apache Pulsar and how, as he mentioned, is such a important backbone of their, technology platform infrastructure, and so he'll be able to share that, right? So with that, let's get started. So again, very quickly for the benefit of folks who are not familiar with Stream Native is a company created by founders of Apache Pulsar. Back in 2012, Apache Pulsar was created as a streaming and messaging open source technology at Yahoo. It was open sourced, and then it was a top level project in 2018. In 2019, company was formed to offer fully managed services for Apache Pulsar. And then I think that was really an amazing period in terms of growth in the open source community and also for the company. Early 2024, we also decided to kind of support Kafka. So all the great capabilities of the Pulsar infrastructure underneath now are accessible through different protocols, actually multiple protocols like Pulsar, Kafka, and MQTT, right? So, so I think if you were to take away one thing, Stream Native is just not a Pulsar company. You can access all the awesome stuffs of all the great capabilities of Pulsar infrastructure via Kafka or MQTT as well, right? Okay, so Pulsar is open source technology for streaming and messaging. We are going to focus a lot more on messaging today rather than streaming. We've got a lot of other sessions on streaming before, but we want to bring you a series of sessions on messaging capabilities. I feel that that's one area which is not being kind of, not a lot of people are not aware of all the great things within that technology. So we want to bring those to you in a series of sessions. So let's start with some of the use cases. Look, message queuing technology has been around for a long time. There's so many use cases associated with queuing and in terms of the importance of it and where that gets used. I'll just touch upon one or two. So workflow orchestration, let's pick that as an example, right? So if you have scenarios like, let's pick a simple scenario like video transcoding, right? Something where you upload a video file, which could be in any file format or encoding. You want to sort of go through different stages of transcoding. You want to extract data, metadata, and then you want to transcode the file to H.264 encoding format, and then push that file or different versions of that file to different stages. So I think these are different steps, right? And then you want to actually, your workflow of how you want to execute a series of steps. You want to track those steps. Some of those might be happening synchronously. Some will happen most of them will be asynchronous. So you need a good resilient infrastructure which allows you to kind of track all that workflow very easily so that you can do that, perform your workflows at scale, right? Other things are again event-driven architecture. Right? Anything where, let's say, let's take an example of a user sign-up flow, right? It's very common. You have a trial experience for your cloud. You want users to come and sign up, and you want to track all their steps right from the beginning till from the sign up to kind of conversion of that user into a perhaps a paid user. So there's so many different stages you can track from sign up to like the first perhaps application the user creates, or and you have different other events happening behind the scenes which you want to log, right? So for all these things you need robust infrastructure. When Asher talks about his success story, he's going to touch upon I think a lot of these use cases, some of these if not all, are what you will hear, definitely workflow orchestration and some of the other ones. So I think a lot of use cases are popular for where like message queuing infrastructure gets used as a infrastructure, right? Now, let's talk a little bit about agentic AI. So that's definitely top of mind, like for most companies and organizations, in terms of like exploration, or a lot of companies are way ahead in implementing any agentic AI related capabilities, which are very specific to their use cases, right? So I think one of the common things which we see as a pattern is like, again, agentic AI, can I something which really operates, all these agents operate in a very unpredictable environment. They need capability to kind of fail and then bounce back and, some sort of notification of failures happening at different stages. So they look for like, this different types of infrastructure which is resilient and gives them that ability to kind of be able to execute these different tasks at a scale, right? So that's where you would see that even though Apache Pulsar was created a long time back and was not really, it was very the messaging capabilities were very focused around, the messaging use cases and making the infrastructure more resilient for that. But naturally, some of these capabilities are fitting well into what the agentic era actually needs, and like which is a combination of either a unified messaging capability with streaming and in messaging part of the same technology, or particularly around fine-grained acknowledgement. As every step happens asynchronously, you want acknowledgement and resilience being actually one of the important categories where essentially you track all your failures and then you do automatic retries and things like that, right? So we will do perhaps separate session and go deeper into how Apache Pulsar's message queuing capabilities can be a good option for being used as a infrastructure for agentic AI, and how larger companies can perform scalable operations on it. But for today, we'll keep the focus more on the message queuing capabilities, the core message queuing, right? So with that, actually, just wanted to highlight one more thing that ever since Apache Pulsar was kind of open source and launched, there's been actually a continuous focus, not just on streaming, but on the messaging capabilities, and a lot of improvements have been rolled out within the open source stack related to message queuing. This is again to look back at what the end-to-end journey of any typical message queuing infrastructure requires, and what are some of the gaps, and what should we add to kind of make it more complete, more stable. So these are a lot of pips which are rolled out over time, which actually really given the confidence to a lot of enterprises and large organizations to adopt this technology with confidence within their platforms, right? So when you get a chance, definitely take a look at these pips, but just want to like flash this for your visibility. So with that, I'm going to actually hand it over to Larry to cover more details about our message queuing capabilities. Larry?
First, I'll start here. So first, we will compare streaming and message queuing and what we mean with these two different worlds. So in streaming, it's about this append-only log abstraction, which became well known with Apache Kafka. And there, you're doing data processing in order on a single partition, and there's very high performance. You could handle a large amounts of reads, and you could ingest large amounts of data, and you could have like different retention periods for data depending on your requirements. And here the scaling mainly happens by adding more topic partitions. In message queuing, one of the key properties is that you have acknowledgement of individual messages so that you could add and remove consumers dynamically. And when a consumer faces a message that it cannot process, this doesn't block progress from processing other messages. So there's ways to redeliver failed messages and possibly schedule them for later delivery. And also there could be capabilities of scheduling messages to be delivered to consumers. So one point here is that Pulsar is on both sides. So when you're using Pulsar, you get the best of both worlds. So you don't have to choose just to do streaming or message queuing, but you could really choose the features based on your requirements and use cases. Next slide, please. In the message queues in Apache Pulsar is implemented in a certain way, which I'll be explaining here. So in Pulsar, we don't have a concept that is called a queue, and messages are stored in Pulsar topics. And in the way how topic becomes a queue is that between topic and a consumer, there's a binding that is called a subscription. And essentially, this subscription is a separate logical queue for the same source messages in this topic. And there's properties that one topic can have several subscriptions at the same time. And this subscription, since it's a queue, that's the one that tracks which messages are consumed and acknowledged by a consumer. And all this flexibility, this provides a lot of different features and capabilities in Pulsar. For example, you have the capability for retention in the topic, and this way you could later on replay messages in a completely separate subscription. And for example, let's say you're doing analytics, you could process them later on, or investigate something that has happened in the past, like some kind of like historical analysis. And this type of features could also be useful for AI use cases where you're consuming your AI agents are consuming the messages that are published in your topics. And this is a very powerful feature compared to how Apache Kafka's retention is built, since there's a mode that you could also have it by default. Pulsar configures it in a way that the storage space is released after all the subscriptions for that topic have caught up. So when you don't need those messages anymore, the storage gets released for other use. And this way, you could be processing a lot of data in your system without having to worry about running out of disk space. which is compared to Kafka. You typically have to have a fixed retention period. So in Pulsar, you could dynamically also change this later on when you want to increase the retention period. And then there's also like different features around retaining messages in tiered storage and lakehouse storage and so on. Next slide, please. In Pulsar, the subscription type specifies how consumers will receive the topics messages, and this is how the queue behaves differently for different use cases. Exclusive and failover subscription, they're about the same type, but the difference is that in exclusive, you could have only one consumer consuming, and others will fail if they try to use that subscription. In failover subscription, you'd be you could have multiple applications that connect, but they're in standby mode, waiting to take over if the primary consumer fails. And the use case for this is when you want to process all the messages in that topic partition in order. The other two types are shared and key shared, and these are ones which allow scaling message processing. Shared is used in cases where you don't need to process the messages in order, but you just want to distribute them out to multiple consumers. And key shared has the capability that you could ensure that all messages with the same key, let's say it's your customer ID or order ID, they get processed by the same consumer. And this is important in certain cases where the consecutive messages have a meaning for the application on the other side. Next slide, please. So kind of like summarizing a little bit these key requirements of distributed work queues, which is one of the common use cases for Pulsar and these shared and key shared subscriptions. So in a work queue use case, each task would be placed in a message and put on that topic. And this is to distribute the work across multiple workers. And there is a requirement that you want to be able to add more workers to scale the processing so you could perform the work faster. And there's also a requirement for having ways to handle different failure cases when the processing of a message fails, so that you're not causing this situation where all progress gets blocked by a single message that is in front of the queue. So there's ways to retry that processing later, or retrying that with the exponential backoff and so on. And in these cases, Pulsar, well, it's kind of like a general requirement that key order processing is typically a common requirement for distributed work queues as well, as mentioned earlier. And for decoupling the producers and consumers, you also want to have some message schema evolution support at the message level in your messaging system. Next slide, please. So in Pulsar, you have 3 levels of elasticity. So you could scale the consumers, which we were talking a lot about, and this allows you to process messages faster when you add more consumers. And in Pulsar, it's about these shared and key shared. And the benefit in Pulsar is that you're not fixed to the ways how your messages are stored in topics and partitions. So you don't need to add more partitions to be able to add more consumers. And then on the messaging cluster side, there's a separation of compute and storage. So in Pulsar, you have these stateless brokers, and you could scale these without doing any data movement from one broker to another, no rebalancing involved. So this allows to manage more topics, more clients with very high throughput. And for the storage layer in Pulsar, it's handled by Apache Bookkeeper. There you could add more storage nodes, which are called bookies, and that allows you to expand the storage space. So you could add new nodes, and you immediately get more available storage space. And then for both the brokers and bookies, there's also ways to downscale so you could also save infrastructure cost. Next slide, please. So Pulsar has many features, but I'd like to mention one of them, which is built-in georeplication. In Pulsar, you have both asynchronous georeplication and synchronous georeplication. And this provides support for many disaster recovery use cases and also low latency use cases, where it would be simply cause too much latency if all the consumers would be connecting over a long distance. Next slide, please. So in summary, in Pulsar, we have unified messaging, which combines streaming and queuing in one platform. You don't need different systems for handling these two. It's AI ready. You have the features that are required for AI workflows. It's cloud native. It's for example, in Pulsar, it's been deployable on Kubernetes for a very long time, and most users are deploying it on Kubernetes in a cloud native fashion. And there's also integrations to analytics systems, so that you could query the data in your data lake and have integration in that manner as well, and many more integrations and for different systems, but we won't be covering that. So from here, I'll be handing it off to Asher. Please go ahead.
Thanks, Larry. That was great. Hi, everyone. Just if you joined late, I'm Asher Goldberg. I'm an engineering manager at Iterable. Iterable, we'll get to in a second, is a company that's used Pulsar for a really long time now. And I'm going to walk everyone through today a bit about how we scaled our company with Pulsar and how today we process billions of messages a day with Pulsar to power what we call our moments-based marketing platform. All right, next slide, please. Okay, so just a quick overview. What is Iterable? There's a bunch of words here. We don't have to read all of them, but Iterable is a SaaS marketing platform. Think of it as sort of a customer lifecycle management platform, not just a CRM, but more of the entire customer lifecycle management. All the communication back and forth with the customers from our customers All the data that we ingest and store on behalf of our customers is all put together and lets our customers work with their customers to both, expand their marketing capabilities, but also keep their users engaged with their companies and everything that they're doing. So let's see how we do it. Next slide, please. Okay, so Iterable operates across many, many use cases. These are just a few examples in the different verticals of the companies that are Iterable customers. We obviously aren't going to read each logo out loud, but just to give you some idea that there isn't really like a single specific area or even size of company that Iterable is in. We have very small companies that send a few thousand messages a week to enormous enterprise customers that send hundreds of millions of messages a week, and it very much scales accordingly for them depending on their each individual's brand and their needs. Next slide, please. The way that Iterable works, sort of our like kind of Iterable data pipeline secret sauce, if you want to call it that, is we take data from basically anywhere. So users so our customers, their customers, provide data to us through various APIs and ingestion and queuing and Kafka streaming and all that sort of stuff. We take that data, it all comes into a lot of different Pulsar topics and queues and namespaces and tenants, which we'll get to in a second. But everything in our company is run through Pulsar at least once. Most of them go through Pulsar multiple different times. Data comes in, communications go out, webhooks go out a different queue, tracks for all those events go somewhere else. And all of that data is running through Pulsar, to the order of something like 50 billion or so messages a day. And each different medium along the bottom here, so email, SMS, WhatsApp, embedded messaging, all of those are different platforms that we support for our customers. To Pulsar, they're relatively the same, which is a cool thing with Pulsar. We don't have to really treat anything differently in terms of like an email versus a WhatsApp message versus any other type of send that we're doing. It's just different queues with different names with different consumers. And everything works, very, very easily. And the barrier to entry for new use cases is, quite low at this point for our other engineering teams. So next slide, please. We're going to talk on the next couple slides about how Iterable divides workloads, or what we call workloads. So I just wanted to quickly explain, like, when we're using the term workload, like what we're talking about, and why Iterable is very unique in its Pulsar usage. So a workload is a distinct product usage by a single Iterable customer. This is obviously not an exhaustive list. This is only a few examples of what could be a workload. But something like a scheduled email that reminds users about an upcoming concert. And the important word there is scheduled, because we're very big users of delayed and delayed delivery tracking and messages that are going to be sent at some later date in the future. A series of messages that every user receives on making a purchase. So if you buy something from one of our customers, a lot of times that order confirmation email that you get is actually coming from Iterable. You wouldn't know it because obviously we don't put our name on it. It's the customer's email. But that data is of what you purchased and how you purchased and what was in your cart and what you took out of your cart. All of that is being sent to Iterable. And then that transactional send at the end, like, hey, thanks for your order, is coming through a Pulsar queue. And we prioritize, certain types of messages like transactional messages like order confirmations or password resets over like, here's a monthly newsletter that, can go out over the course of a few hours versus needing to be sent, right now. The other two, just other examples of, sends that we're doing. But the important part here is that Iterable has many different workloads, each of which has their own requirements. It could be a SLA for the time that the email has to be arrived by. It could just be the frequency in which these queues are getting, new messages and how our consumers are all working together. But just keep workloads in mind as we go through the next couple slides about how we use all this together in practice. Next one, please. Okay, so these are Iterable's kind of core principles for queuing. And these came into play when we were selecting a new queuing platform, which was Pulsar. We've been using Pulsar now for I think about 5 years we started migrating from RabbitMQ into Pulsar, and for about 3 years now we've been exclusively on Pulsar. So there was definitely a time period where some of our stuff was in one system, some of the stuff was in another. But for the last 3 years or so, we've been exclusively on Pulsar. Our three kind of core principles are that the platform has to be scalable, flexible, and fair. And all of these kind of come into play with the different ways in which our customers use Iterable. So it has to be scalable. It has to support hundreds of thousands of workloads running in parallel. So we had that previous slide with the example of a single workload. We're doing that hundreds of thousands of times all the time, basically, because every customer is slightly different, and we don't have customers overlapping on the same topics, which goes to the fair column, which we'll get to in a second. Um, Pulsar also can adapt to rapid changes in scale. You'll see in the next couple slides, Iterable's volume is not constant. Emails are sent, there's a heavy emphasis on emails being sent at like the top of the hour on a daily basis. But then also there's, large events like Black Friday, Cyber Monday, the lead up to Christmas, the US election cycles. All of these contribute to huge spikes in volume. And we don't really have to worry about it from my team's standpoint because Pulsar can just easily adapt to that additional scale and handle the load. Um, Under flexible for different new use cases. So we're constantly adding new things into Pulsar, and there's no work that we really have to do to get Pulsar to support that new use case. Everything is just kind of built in out of the box that we need. One of the major items that we were looking for when we selected a new platform was a first-class support for delayed message delivery. We are very heavy users of delayed message delivery. We have messages that can be scheduled up to 60 days in advance. And so if you're a marketer on our team and you put in, hey, 60 days out, like you need to know that that message is going to get sent exactly when you said it was going to get sent. Um, and then on the flip side, at the individual message level, even we have like a AI driven feature that we call send time optimization that basically takes into account for every user that we have, when's the best time to send them an email. And it could be as simple as that user's in a different time zone and we don't want to send them an email at 2 in the morning. But it could also be because we're tracking the email opens. We know that these users tend to open their emails, at 5 p.m. and later versus at 10 a.m. But for our marketers, that's very annoying to schedule different tiers of campaigns with different times. So if they enable send time optimization and they're sending to 100 million, messages, Pulsar will track an individual different delayed stamp for every single message in that campaign. And they can all be mixed together, all in a different order. They don't have to be ordered. Our consumers does not make a difference. And Pulsar will deliver those messages to the consumers exactly when they hit the time that they're supposed to be sent. So that's like large campaign level, but also individual message level. And then finally, for fairness, we have a very heavy emphasis on customer isolation, not just so much from a security standpoint, which is obviously important with the amount of data that we're handling, but more for the fact that all of our customers are different sizes. And even though we have customers that are, like we said, enterprise level customers versus some of our small ones, we still want to maintain the same quality of service for our smaller customers as we do for the big ones. And that means we always have to dedicate a certain amount of resources to every single customer. And we do that through individual Pulsar namespaces and topics for each customer. So rather than have a gigantic queue for all outbound emails that need to be sent with many partitions, we instead have individual, namespaces for each customer, and then individual topics for each campaign. And this is ensuring that we always are giving, adequate resourcing to everything that is happening at the same time. So those are our three kind of core principles. You'll see how that plays in, in the next couple slides. So next one, please. So this is, basically why we ended up choosing Pulsar. Reason number one is its scalability, like we said, millions of topics, producers, and consumers. On a normal day, these are about our statistics for a normal day for us now. Our peak publish rate on a normal day, that's messages per second, is a little over 1 million messages per second, or about 1.25 million messages per second. But again, our volume is very spiky throughout the day, so we're not getting that constantly. But our total messages a day through all of our clusters, we have 8 across our different environments. Through all of our clusters is about 50 billion messages a day. That's a mix of internal event tracking, system events, customer lifecycle events, outbound sends, like we were talking about, all that sort of stuff. Um, Outbound sends typically is only about 1 billion messages a day for outbound sends. So the other, 49 billion is mostly how customers move through our system and events that we ingest on behalf of our customers. On a normal day, we have about 100,000 active topics, about 500,000 producers for various use cases, and then about around 2 million consumers. And again, our consumers are designed in such a way that they're subscribing to a single workload, a group of workloads, many workloads, but they're all a little bit different depending on the specific use case and how we want to enforce, certain customer priorities. Like we said, first class support for delayed messages, multiple consumption models. We typically, for the most part, only use shared consumers, but having those other models and modes for the consumers is obviously very helpful for certain cases. And then the last one is built-in DLQ capabilities, especially for us on our outbound sends. So for us, we use a lot of ESP and sending providers, Twilio, Telenex, those sorts of providers. If they have an outbound outage from us, obviously we don't want our outbound sends to be lost forever. We would prefer that they go through on the first try, but we all know that's not necessarily always possible. So Pulsar's built-in DLQ will sideline those messages that were failed to be sent for whatever reason, and then our engineering teams can take a look through the DLQ and decide, if they want to redrive the messages, how they want to redrive the messages, and all of that's being handled automatically. Um, and then the last part, similar to DLQ, is how we enable topic level retention for ours for these topics. All of our topics have a retention policy on for some for 3 hours, some for as much as 24 hours, and it just gives us the flexibility to rewind that topic and replay the messages very easily if there's ever some sort of outage or issue with one of our providers. Okay, next one, please. So this is how we were saying about our burst in traffic. That top graph shows our kind of daily spikes in traffic. So, you can see like obviously it's on the left to the left of the graph, but around 9 a.m., there was a larger spike, and then throughout the middle of the hour, it gets a little lower. Up at 9:30, it spikes up again. Same, smaller spike, but same thing kind of happens around 10 o'clock. And this is mostly a function of how our customers are scheduling their messages, scheduling their campaigns. We typically target top of the hour just because it's a nice round number to send your messages out at. And Pulsar has to be able to handle that increase, at the top of each hour. In addition to the daily spikes, the graph at the bottom is showing the Pulsar rate in for a period of a few months between September and January this past year, just to sort of illustrate like the volume that comes in per topic or in total gets significantly higher throughout like the holiday season, starting around like early November, middle of November, leading up to Black Friday, and kind of continuing through Christmas. A lot of our customers are in that space where they are, they're selling things, and that's a very high volume time for them, and therefore a very high volume time for us. And Pulsar is flexible enough that, like Laurie was saying, just adding additional brokers or additional bookies is generally all we need to accommodate that load, and it's very easy. As soon as the new brokers or bookies come up, they immediately start either serving traffic or storing data, and there's nothing else we have to do other than, add additional nodes to the cluster. When we're done in January with some of this peak heavy load, we can easily remove brokers. They're stateless. There's no problem with removing a broker from the list of brokers. Bookies require slightly more time. They have to run through a decommission process on Bookkeeper, but still it's very easy to remove that extra scale that we've put in for a few times a year. Okay, next slide, please. So this is just a brief overview on our topic architecture and why Pulsar works so well for us. We have different types of topics. So in this case, it's transactional topics and bulk topics. Transactional topics are like, here's your order or here's your password reset. Bulk is like, here are, specials for the month or something along those lines. We will prioritize different types of work for different types of customers depending on either what they want or what we need to do to protect our system, to ensure that no single customer is sending too many messages or something like that. So for example, on like where it says like org 1 consumer and org 2 consumer, imagine those as like outbound email providers, and org 1 and org 2 have different rate limits for themselves. And we need to keep track for ourselves that they only want us to send 250 messages a second or 100 messages a second. So we're tracking per customer rate limits. And the way we are able to enforce that is with our topic structure. Without separating the different topics, we would never be able to do that, because you wouldn't know how many messages are coming until you actually got them. So by separating the topics at the beginning, we can then enforce these rate limits and provide our customers with the level of service they want. Um, we also only use regex-based consumers at Iterable, even if we're subscribing to one topic, just to give us the added flexibility. So, for example, this transactional consumer can subscribe to any topic with the word transactional in it, and that makes it a lot easier. The org 1 consumer can subscribe to any topic with org 1 in it, and that also makes things a little bit easier. And all of our subscriptions are shared, and you can have multiple subscriptions for each topic, for different use cases. So for example, our email topics, our outbound sends have subscription to actually send the email, but also another subscription for the internal event tracking that we use around the email being sent at all. And both of those subscriptions are running at the same time on different consumers with no added pressure on the topic. Pulsar makes no difference how many subscriptions there. I mean, maybe at 100, but certainly not at one versus a few subscriptions does not make a difference for us. And we're able to have that flexibility for however we want to structure our topics. Um, we also are able to apply, different types of back pressure and rate limiting depending on what our customers have asked for us. So either we can't go fast enough or they want us to go faster. And either way, we're able to have that flexibility with Pulsar. All right, next slide, please. And then finally, this is the advantages to us using Pulsar. Um, the lower cost of scaling for us has been basically allowed the company to scale in this way. When we were on RabbitMQ previously, we had far less traffic, um, and we were spending a lot more back then, 4 years ago, 5 years ago, than we do with Pulsar today. And that was with a lot less customers and a lot less different use cases running through Pulsar. Um, Pulsar's advanced feature set, some of which Laurie was, discussing in his slides, give us much more valuable and reliability for the money. We were really struggling with RabbitMQ before with the with the lack of high availability, issues with delayed delivery messages, just the way that the nodes could never really replicate to each other because of our sheer volume, and all of those problems, go away with Pulsar's feature set. We don't cover it here, but we're also heavy users of Pulsar connectors, some of which are open source, some of which are Stream Native proprietary connectors. But we offload messages to S3. We ingest stuff from SQS. We have some Pulsar syncs that send our data directly to Snowflake for some of our analytics teams. All of that feature set, is basically capable with the core Pulsar, infrastructure, and it allows us this additional added flexibility that we never had previously. Um, that's on the, financial cost of the company. But there's obviously a whole nother section of this, which is the engineering time and the engineering cost of the company. We no longer have to spend, months onboarding a new use case. My team writes pretty much like standard queuing libraries that every other team uses. And all they have to do is just hook up their service to Pulsar. Um, We've made it considerably easier to get started. Pulsar's scalability, it allows us to not have to worry about it. So unless a new use case is coming on with I don't know, 200,000 messages a second of volume, we will not even notice the increase. So our engineering teams could add an additional 50,000 messages per second, 100,000 messages per second, and Pulsar could handle that at our current scale without any real issue. Um, we also don't have to be worried about the company growth being limited by the queuing system. So we don't have to work. Product can, invent and sell whatever features they want to our customers. And we know that all that feature work will eventually run back through Pulsar in some way or another, but there's no longer a need to worry that we can't keep up with what product is selling, which is a very different paradigm than it was here a few years ago, and really has allowed us to unlock a ton of new features and revenue, with Pulsar kind of at its center. Um, and then finally, that last one, we don't have to worry about rapid changes in customer usage impacting our platform. So if our customers are typically sending 1,000 messages a day and all of a sudden they go up to 100,000 messages a day, we'll see the increase. But the way we structure our consumers, the way we implement rate limiting and back pressure, it's not like we'll get all 100,000 messages at 1 second. And it will, it's not like it will immediately overwhelm our platform or anything like that. So, all of these things together, it's been a really great road for us to start using Pulsar to start working on some of the more advanced Pulsar features. We have certainly grown a lot since we started using it. And I would like to say that most of our growth has really been possible by the features that Pulsar has unlocked for our company and the way in which we're able to service our customers in a way they're expecting, maintain our very low SLAs for our customers, and keep the performance where everyone is happy. Okay, so that was the last of my slides about Iterable, and I'll send it back to Kundan.
Cool. Sounds great. Well, that was a great session. Thank you so much, Asher. I think there are a lot of interesting nuggets there, a lot of wisdom which you've shared in terms of your experience working with Pulsar. So hopefully, our audience found that helpful. So thanks again, Asher. And just to share some more details here, for any of the folks who are new to StreamNet, if you want to sign up for a trial to get your hands on these capabilities within StreamNet platform, both streaming and messaging, you can sign up for a trial by scanning this or going to this, or you can also schedule a demo with us. All right. So we also have some other resources to share today. I think, David from Stream Native has written a very nice book on Apache Pulsar. Messaging is a big part of that. I think messaging being the topic for today, I think you'll find a lot of useful information in that. You can just scan this barcode to get that free copy of your book to your email. Feel free to go through that when you get a chance. The other thing is whatever Asher covered, I think, we have published this in our site as well. If you want to go through the success story, you might find some other types of information there. But I think what Asher covered today was very, very much in detail and very helpful. So if you want to scan this to learn more about the success story of Iterable, I think, you can do that as well. One last thing here, Data Streaming Summit is coming up. It is an event which is organized by StreamNative. This event was called Pulsar Summit before, but now that we are focused on, like we made made this event open for all kind of streaming topics, not just very focused to Pulsar. So, or Kafka, any streaming technology or topic is kind of welcome. So feel free to explore more about this event by scanning this code. If you want to attend this event, you can, learn more about how to kind of sign up for it. If you want to, as a company, sponsor at this event, you can definitely reach out to us. You can either DM me directly on LinkedIn or, reach out to us through the contact section. There's also, while I think we pretty much closed now the sessions, the submissions for the sessions. If you still are very strongly interested in presenting at Data Streaming Summit, you can very much reach out to me. I can explore if we have a slot available to have you present at the event. This is a very popular event. Last year, we had a lot of good attendance from a larger enterprises, and they all shared a lot of experiences about their stream leverage of streaming technology. So um, feel free to explore this more. Okay, so if you want to learn more about Iterable, I think you can scan that barcode. Asher covered more details about the company in the beginning, but if you want to learn more about them, definitely check out their website, scan this barcode. Thank you so much for joining the session, everyone who's participated. You all have a nice day. Yeah, thank you.
Thanks, everyone.
Thank you. Bye.